Session number 6. Good day. Today we will talk about research methodology and project proposal preparation. My goals for course that each of you develop an intuition for the fundamental principles of research methodology, that we have an enjoyable semester learning together. Contents: the aims of research, the research topic, title and research problem, literature review, research design, population and sampling types, types of quantitative research designs, validity of conclusions, data collecting methods and measuring instruments in quantitative research, qualitative research designs, data analysis and interpretation of results, report writing and the research proposal, ethical consideration on research. Overview of science and the scientific method. Science can be defined as a methodological and systematic approach to the acquisition of new knowledge. This definition of science highlights some of the key differences between how scientists and non-scientists go about acquiring new knowledge. Specifically, rather than relying on mere casual observations and an informal approach to learn about the world, scientists attempt to gain new knowledge by making careful observations and using systematic, controlled, and methodical approaches. Shaughnessy and Zechmeister, 1997. In addition, scientific knowledge is not based on the opinions, feelings, or intuition of the scientist. Instead, scientific knowledge is based on objective data that were reliably obtained in the context of a carefully designed research study. In short, scientific knowledge is based on the accumulation of empirical evidence. Kasdan, 2003a. The defining characteristic of scientific research is the scientific method, first described by the English philosopher and scientist Roger Bacon in the 13th century. It is still generally agreed that the scientific method is the basis for all scientific investigation. The scientific method is best thought of as an approach to the acquisition of new knowledge. And this approach effectively distinguishes science from non-science. The scientific method. The development of the scientific method is usually credited to Roger Bacon, a philosopher and scientist from 13th century England. Although some argue that the Italian scientist Galileo Galilei played an important role in formulating the scientific method. Later contributions to the scientific method were made by the philosophers Francis Bacon and René Descartes. Although some disagreement exists regarding the exact characteristics of the scientific method, most agree that it is characterized by the following elements: empirical approach, observations, questions, hypotheses, experiments, analyses, conclusions, replication. Empirical approach. The scientific method is firmly based on the empirical approach. The empirical approach is an evidence-based approach that relies on direct observation and experimentation in the acquisition of new knowledge. See Kasdan, 2003a. In the empirical approach, scientific decisions are made based on the data derived from direct observation and experimentation. Contrast this approach to decision-making with the way that most non-scientific decisions are made in our daily lives. For example, we have all made decisions based on feelings, hunches, or gut instinct. Additionally, we may often reach conclusions or make decisions that are not necessarily based on data, but rather on opinions, speculation, and a hope for the best. The empirical approach, with its emphasis on direct, systematic, and careful observation, is best thought of as the guiding principle behind all research conducted in accordance with the scientific method. Observations. An important component in any scientific investigation is observation. In this sense, observation refers to two distinct concepts: being aware of the world around us and making careful measurements. Observations of the world around us often give rise to the questions that are addressed through scientific research. For example, the Newtonian observation that apples fall from trees stimulated much research into the effects of gravity. Therefore, a keen eye to your surroundings can often provide you with many ideas for research studies. Questions after getting a research idea, perhaps from making observations of the world around us. The next step in the research process involves translating that research idea into an answerable question. The term answerable is particularly important in this respect, and it should not be overlooked. It would obviously be a frustrating and ultimately unrewarding endeavor to attempt to answer an unanswerable research question through scientific investigation. It is therefore important to formulate a research question that can be answered through available scientific methods and procedures. Hypotheses. The next step in the scientific method is coming up with a hypothesis, which is simply an educated and testable guess about the answer to your research question. A hypothesis is often described as an attempt by the researcher to explain the phenomenon of interest. Hypotheses can take various forms, depending on the question being asked and the type of study being conducted. A key feature of all hypotheses is that each must make a prediction. Remember that hypotheses are the researcher's attempt to explain the phenomenon being studied, and that explanation should involve a prediction about the variables being studied. These predictions are then tested by gathering and analyzing data, and the hypotheses can either be supported or refuted on the basis of the data. Two types of hypotheses with which you should be familiar are the null hypothesis and the alternate, or experimental, hypothesis. The null hypothesis always predicts that there will be no differences between the groups being studied. By contrast, the alternate hypothesis predicts that there will be a difference between the groups. For example, the null hypothesis would predict that the exercise group and the no-exercise group will not differ significantly on levels of cholesterol. The alternate hypothesis would predict that the two groups will differ significantly on cholesterol levels. Homework. Individual, please try to find one example about the null hypotheses and alternate hypotheses. Experiments. After articulating the hypothesis, the next step involves actually conducting the experiment or research study. For example, if the study involves investigating the effects of exercise on levels of cholesterol, the researcher would design and conduct a study that would attempt to address that question. As previously mentioned, a key aspect of conducting a research study is measuring the phenomenon of interest in an accurate and reliable manner. In this example, the researcher would collect data on the cholesterol levels of the study participants by using an accurate and reliable measurement device. Then, the researcher would compare the cholesterol levels of the two groups to see if exercise had any effects. Accuracy versus reliability. When talking about measurement in the context of research, there is an important distinction between being accurate and being reliable. Accuracy refers to whether the measurement is correct, whereas reliability refers to whether the measurement is consistent. An example may help to clarify the distinction. When throwing darts at a dartboard, accuracy refers to whether the darts are hitting the bullseye. An accurate dart thrower will throw darts that hit the bullseye. Reliability, on the other hand, refers to whether the darts are hitting the same spot. A reliable dart thrower will throw darts that hit the same spot. Therefore, an accurate and reliable dart thrower will consistently throw the darts in the bullseye. As may be evident, however, it is possible for the dart thrower to be reliable, but not accurate. For example, the dart thrower may throw all of the darts in the same spot, which demonstrates high reliability, but that spot may not be the bullseye, which demonstrates low accuracy. Analyses. After conducting the study and gathering the data, the next step involves analyzing the data, which generally calls for the use of statistical techniques. The type of statistical techniques used by a researcher depends on the design of the study, the type of data being gathered, and the questions being asked. It is important to be aware of the role of statistics in conducting a research study. In short, statistics help researchers minimize the likelihood of reaching an erroneous conclusion about the relationship between the variables being studied. Conclusions. After analyzing the data and determining whether to reject the null hypothesis, the researcher is now in a position to draw some conclusions about the results of the study. For example, if the researcher rejected the null hypothesis, the researcher could conclude that the phenomenon being studied had an effect, a statistically significant effect, to be more precise. If the researcher rejects the null hypothesis in our exercise cholesterol example, the researcher is concluding that exercise had an effect on levels of cholesterol. It is important that researchers make only those conclusions that can be supported by the data analyses. Going beyond the data is a cardinal sin that researchers must be careful to avoid. Replication. One of the most important elements of the scientific method is replication. Replication essentially means conducting the same research study a second time with another group of participants to see whether the same results are obtained. The same researcher may attempt to replicate previously obtained results, or perhaps other researchers may undertake that task. Replication illustrates an important point about scientific research, namely, that researchers should avoid drawing broad conclusions based on the results of a single research study because it is always possible that the results of that particular study were an aberration. In other words, it is possible that the results of the research study were obtained by chance or error, therefore, that the results may not accurately represent the actual state of things. However, if the results of a research study are obtained a second time, i.e., replicated, the likelihood that the original study's findings were obtained by chance or error is greatly reduced. Information, in its most restricted technical sense, is a sequence of symbols that can be interpreted as a message. Information can be recorded as signs, or transmitted as signals. Information is any kind of event that affects the state of a dynamic system that can interpret the information. Conceptually, information is the message, utterance or expression, being conveyed. Therefore, in a general sense, information is knowledge communicated or received concerning a particular fact or circumstance, or rather, information is an answer to a question. Citation needed. Information cannot be predicted and resolves uncertainty. The uncertainty of an event is measured by its probability of occurrence and is inversely proportional to that. The more uncertain an event, the more information is required to resolve uncertainty of that event. The amount of information is measured in bits. Example, information in 1, fair coin IP, log 2, 2/1, equals 1 bit. And in 2 fair coin flips is log 2, 4/1, equals 2 bits. The concept that information is the message has different meanings in different contexts. Thus the concept of information becomes closely related to notions of constraint, communication, control, data, form, disambiguation needed, instruction, knowledge, meaning, understanding, mental stimuli, pattern, perception, representation, and entropy. Etymology. See also, history of the word and concept information. The English word was apparently derived from the Latin stem information, of the nominative informatio. This noun is derived from the verb informere, to inform, in the sense of to give form to the mind, to discipline, instruct, teach. Men so wise should go and inform their kings. 1330. Inform itself comes via French informer, from the Latin verb informere, which means to give form, or to form an idea of. Furthermore, Latin itself already contained the word informatio, meaning concept or idea, but the extent to which this may have influenced the development of the word information in English is not clear. The ancient Greek word for form was morphe, cf, morph, and also eidos, kind, idea, shape, set. The latter word was famously used in a technical philosophical sense by Plato, and later Aristotle, to denote the ideal identity or essence of something. See theory of forms. Eidos can also be associated with thought, proposition, or even concept. Information theory approach from the stance of information theory. Information is taken as a sequence of symbols from an alphabet, say an input alphabet chi, and an output alphabet y. Information processing consists of an input-output function that maps any input sequence from chi into an output sequence from y. The mapping may be probabilistic or determinate. It may have memory or be memoryless. As sensory input, often information can be viewed as a type of input to an organism or system. Inputs are of two kinds. Some inputs are important to the function of the organism, for example, food or system, energy, by themselves. In his book Sensory Ecology, Dusenbury called these causal inputs. Other inputs, information, are important only because they are associated with causal inputs and can be used to predict the occurrence of a causal input at a later time, and perhaps another place. Some information is important because of association with other information, but eventually there must be a connection to a causal input. In practice, information is usually carried by weak stimuli that must be detected by specialized sensory systems and amplified by energy inputs before they can be functional to the organism or system. For example, light is often a causal input to plants but provides information to animals. The colored light reflected from a flower is too weak to do much photosynthetic work, but the visual system of the bee detects it and the bee's nervous system uses the information to guide the bee to the flower, where the bee often finds nectar or pollen, which are causal inputs, serving a nutritional function. As representation and complexity, the cognitive scientist and applied mathematician Ronaldo Vigo argues that information is a concept that involves at least two related entities in order to make quantitative sense. These are any dimensionally defined category of objects S, and any of its subsets R, in essence, is a representation of S, or, in other words, conveys representational, and hence conceptual information about S. Vigo then defines the amount of information that R conveys about S as the rate of change in the complexity of S whenever the objects in R are removed from S. Under Vigo information, pattern, invariance, complexity, representation, and information, 5 fundamental constructs of universal science, are unified under a novel mathematical framework. Among other things, the framework aims to overcome the limitations of Shannon-Weaver information when attempting to characterize and measure subjective information. As an influence which leads to a transformation, information is any type of pattern that influences the formation or transformation of other patterns. 6-7, in this sense. There is no need for a conscious mind to perceive, much less appreciate, the pattern. Citation needed. Consider, for example, DNA. The sequence of nucleotides is a pattern that influences the formation and development of an organism without any need for a conscious mind. Systems theory at times seems to refer to information in this sense, assuming information does not necessarily involve any conscious mind. And patterns circulating, due to feedback, in the system can be called information. In other words, it can be said that information in this sense is something potentially perceived as representation. though not created or presented for that purpose. For example, Gregory Bateson defines information as a difference that makes a difference. If, however, the premise of influence implies that information has been perceived by a conscious mind and also interpreted by it, the specific context associated with this interpretation may cause the transformation of the information into knowledge. Complex definitions of both information and knowledge make such semantic and logical analysis difficult. But the condition of transformation is an important point in the study of information as it relates to knowledge, especially in the business discipline of knowledge management. In this practice, tools and processes are used to assist a knowledge worker in performing research and making decisions, including steps such as reviewing information in order to effectively derive value and meaning, referencing metadata if any is available, establishing a relevant context, often selecting from many possible contexts, deriving new knowledge from the information, making decisions or recommendations from the resulting knowledge. Stewart, 2001, argues that the transformation of information into knowledge is a critical one, lying at the core of value creation and competitive advantage for the modern enterprise. The Danish Dictionary of Information Terms argues that information only provides an answer to a posed question. Whether the answer provides knowledge depends on the informed person. So a generalized definition of the concept should be, information equals an answer to a specific question. When Marshall McLuhan speaks of media and their effects on human cultures, he refers to the structure of artifacts that in turn shape our behaviors and mindsets. Also, pheromones are often said to be information in this sense. As a property in Physics main article, Physical information has a well-defined meaning in physics. In 2003, J.D. Bekenstein claimed that a growing trend in physics was to define the physical world as being made up of information itself, and thus information is defined in this way. See digital physics. Examples of this include the phenomenon of quantum entanglement, where particles can interact without reference to their separation or the speed of light. Information itself cannot travel faster than light even if the information is transmitted indirectly. This could lead to all attempts at physically observing a particle with an entangled relationship to another being slowed down, even though the particles are not connected in any other way other than by the information they carry. Another link is demonstrated by the Maxwell's demon thought experiment. In this experiment, a direct relationship between information and another physical property, entropy, is demonstrated. A consequence is that it is impossible to destroy information without increasing the entropy of a system. In practical terms, this often means generating heat. Another more philosophical outcome is that information could be thought of as interchangeable with energy, citation needed. Thus, in the study of logic gates, the theoretical lower bound of thermal energy released by an AND gate is higher than for the NOT gate, because information is destroyed in an AND gate and simply converted in a NOT gate. Physical information is of particular importance in the theory of quantum computers. Technologically mediated information. It is estimated that the world's technological capacity to store information grew from 2.6 optimally compressed exabytes in 1986, which is the informational equivalent to less than 1730 MB CD-ROM per person, 539 megabytes per person, to 295 optimally compressed exabytes in 2007-10. This is the informational equivalent of almost 61 CD-ROM per person in 2007. The world's combined technological capacity to receive information through one-way broadcast networks was the informational equivalent of 174 newspapers per person per day in 2007. The the world's combined effective capacity to exchange information through two-way telecommunication networks was the informational equivalent of 6 newspapers per person per day in 2007. As records are specialized forms of information. Essentially, records are information produced consciously or as byproducts of business activities or transactions and retained because of their value. Primarily, their value is as evidence of the activities of the organization, but they may also be retained for their informational value. Sound records management ensures that the integrity of records is preserved for as long as they are required. The International Standard on Records Management, ISO 15489, defines records as information created, received, and maintained as evidence and information by an organization or person, in pursuance of legal obligations or in the transaction of business. The International Committee on Archives, ICA, Committee on Electronic Records, defined a record as a specific piece of recorded information generated, collected or received in the initiation, conduct or completion of an activity and that comprises sufficient content, context and structure to provide proof or evidence of that activity. Records may be maintained to retain corporate memory of the organization or to meet legal, fiscal or accountability requirements imposed on the organization. Willis, 2005, expressed the view that sound management of business records and information delivered. 6 key requirements for good corporate governance: transparency, accountability, due process, compliance, meeting statutory and common law requirements, and security of personal and corporate information and semiotics. Bain and Davies explains the multifaceted concept of information in terms of signs and signal sign systems. Signs themselves can be considered in terms of 4 interdependent levels, layers or branches of semiotics: pragmatics, semantics, syntax, and empirics. These 4 layers serve to connect the social world on the one hand with the physical or technical world on the other. Pragmatics is concerned with the purpose of communication. Pragmatics links the issue of signs with the context within which signs are used. The focus of pragmatics is on the intentions of living agents underlying communicative behavior. In other words, pragmatics link language to action. Semantics is concerned with the meaning of a message conveyed in a communicative act. Semantics considers the content of communication. Semantics is the study of the meaning of signs, the association between signs and behavior. Semantics can be considered as the study of the link between symbols and their reference or concepts, particularly the way in which signs relate to human behavior. Syntax is concerned with the formalism used to represent a message. Syntax is an area that studies the form of communication in terms of the logic and grammar of sign systems. Syntax is devoted to the study of the form rather than the content of signs in sign systems. Empirics is the study of the signals used to carry a message. The physical characteristics of the medium of communication. Empirics is devoted to the study of communication channels and their characteristics, e.g., sound, light, electronic transmission, etc. Nielsen, 2008, discusses the relationship between semiotics and information in relation to dictionaries. The concept of lexicographic information costs is introduced and refers to the effort users of dictionaries need to make in order to first, find the data secondly, understand the data so that they can generate information. Communication normally exists within the context of some social situation. The social situation sets the context for the intentions conveyed, pragmatics, and the form in which communication takes place. In a communicative situation, intentions are expressed through messages which comprise collections of interrelated signs taken from a language which is mutually understood by the agents involved in the communication. Mutual understanding implies that agents involved understand the chosen language in terms of its agreed syntax, syntactics, and semantics. The sender codes the message in the language and sends the message as signals along some communication channel, empirics. The chosen communication channel will have inherent properties which determine outcomes such as the speed with which communication can take place and over what distance. In business, a product could have a shorter life if it can't win the hearts of people and showcase new technology. So Nokia is coming up with a Nokia more flexible mobile phone which the company claims include nanotechnology and would immensely benefit its end users. The main benefit of nanotechnology is that its components are flexible, transparent, and extremely strong. The company believes this latest technology would be a distinctive phone by 2015. But a few technical glitches remain to be solved, like the use of new battery materials, etc. Nokia Morph is a joy technology concept developed by Nokia Research Centre, NRC, and the University of Cambridge, UK. The Morph demonstrate how future mobile device might be stretchable and flexible, allowing the user to transform their mobile devices into radically different shapes. It demonstrates ultimately that nanotechnology might be capable of delivering flexible material, transparent electronics, and self-cleaning surface. Fibril proteins are woven into three-dimensional meshes that reinforce thin elastic structures, using the same principle behind spider silk. This elasticity enables the device to literally change its shapes and configure itself to adapt to the task at hand. MIMO is a software platform developed by Nokia for smartphones and internet tablets. It is based on the Debian Linux distribution. The platform comprises the MIMO operating system and the MIMO SDK. MIMO is mostly based on open source code, and has been developed by MIMO devices within Nokia in collaboration with many open source projects such as the Linux kernel, Debian, and GNOME. MIMO is based on Debian GNU Linux and draws much of its GUI, frameworks, and libraries from the GNOME project. It uses the Matchbox window manager and the GTK-based Hilton as its GUI and application framework. The UI in MIMO 4 is similar to many handheld interfaces, and features a home screen, which acts as a central point from which all applications and settings are accessed. The home screen is divided into areas for launching applications, a menu bar, and a large customizable area that can display information such as an RSS reader, internet radio player, and Google search box. The MIMO 5 UI is slightly different. The menu bar and info area are consolidated to the top of the display, and the four desktops can be customized with shortcuts and widgets. Tripwire is an intrusion detection system. It is a software tool that checks to see what has changed on your system. The program monitors the key attributes of files that should not change, including the size, binary signature, expected change of size, and other related important data. Tripwire is an open-source program created to monitor changes in a key subset of files identified by the user and report on any changes in any of those files. When changes are detected, the system administrator can determine whether those changes occurred due to normal, permitted activity, or whether they were caused by a break-in. If the former, the administrator can update the system baseline to the new files. If the latter, then repair and recovery activity begins. Tripwire's principle is simple enough. The system administrator identifies key files and causes Tripwire to record checksum for those files. Administrator also puts a cron job to scan those files at intervals, daily or more frequently. Comparing to the original checksum, any changes, addition, or deletion are reported so the proper action can be taken. Honeypot is an exciting new technology with enormous potential for the security community. It is a resource which is intended to be attacked and compromised to gain more information about the attacker and his attack techniques. They are a highly flexible tool that comes in many shapes and sizes. This paper deals with understanding what a honeypot actually is and how it works. There are different varieties of honeypots. Based on their category, they have different applications. This paper gives an insight into the use of honeypots in productive as well as educative environments. This paper also discusses the advantages and disadvantages of honeypots, and what the future holds in store for them. The rapid growth of electronic commerce, e-commerce, has necessitated the development of e-commerce protocols. These protocols ensure the confidentiality and integrity of information exchanged. In addition, researchers have identified other desirable properties, such as money atomicity, goods atomicity, and validated receipt that must be satisfied by e-commerce protocols. This seminar shows how model checking can be used to obtain an assurance about the existence of these properties in an e-commerce protocol. It is essential that these desirable properties be satisfied, even in the presence of site or communication failure. Using the model checker, we evaluate which failures cause the violation of one or more of the properties. The results of the analysis are then used to propose a mechanism that handles the failures to make the protocol failure resilient. Fixed power wireless sensor networks are cost-effective and prevalent, and they are facing lots of problems like RF interference, node failure from environmental noise and energy constraints. A routing protocol for fixed power wireless sensor networks must overcome these problems, because it had to achieve reliability, energy efficiency, and scalability in message delivery. In this paper, we propose an efficient and reliable routing protocol that achieves reliable and scalable performance with minimal compromise of energy efficiency. The routing design of EAR is based on 4 parameters: expected path length and a weighted combination of distance traversed, energy levels, and link transmission success history. To dynamically determine and maintain the best routes, we will evaluate the performance of efficient and reliable routing protocols for such networks. Cloud computing is making it possible to separate the process of building an infrastructure for service provisioning from the business of providing end-user services. Today, such infrastructures are normally provided in large data centers and the applications are executed remotely from the users. One reason for this is that cloud computing requires a reasonably stable infrastructure and networking environment, largely due to management reasons. Networking of information, NetInf, is an information-centric networking paradigm that can support cloud computing by providing new possibilities for network transport and storage. It offers direct access to information objects through a simple API, independent of their location in the network. This abstraction can hide much of the complexity of storage and network transport systems that cloud computing today has to deal with. In this paper, we analyze how cloud computing and NetInf can be combined to make cloud computing infrastructures easier to manage, and potentially enable deployment in smaller and more dynamic networking environments. NetInf should thus be understood as an enhancement to the infrastructure for cloud computing rather than a change to cloud computing technology as such. To illustrate the approach taken by NetInf, we also describe how it can be implemented by introducing a specific name resolution and routing mechanism. Voice over Internet Protocol, VoIP, has become a popular alternative to traditional public switched telephone network, PSTN, networks that provides advantages of low cost and flexible advanced digital features. The flexibility of the VoIP system and the convergence of voice and data networks brings with it additional security risks. These are in addition to the common security concerns faced by the underlying IP data network facilities that a VoIP system relies on. The result being that the VoIP network further complicates the security assurance mission faced by enterprises employing this technology. It is time to document various security issues that a VoIP infrastructure may face and analyze the challenges and solutions that may guide future research and development efforts. In this paper, we examine and investigate the concerns and requirements of VoIP security. After a thorough review of security issues and defense mechanisms, we focus on attacks and countermeasures unique to VoIP systems that are essential for current and future VoIP implantations. Then, we analyze two popular industry best practices for securing VoIP networks and conclude this paper with further discussion on future research directions. This paper aims to direct future research efforts and to offer helpful guidelines for practitioners. Multi-touch technology is an advanced human-computer interaction technique that recognizes multiple touch points and also includes the hardware devices that implement it, which allow users to compute without conventional input devices. Multi-touch consists of a touch screen, table, wall, etc., or touchpad, as well as a software that recognizes multiple simultaneous touch points, as opposed to the standard touch screen which recognizes only one touch point at a time. Multi-touch using frustrated total internal reflection is a simple, inexpensive, and scalable technique for enabling high-resolution multi-touch sensing on rear-projected interactive surfaces. Different applications for multi-touch interfaces both exist and are being proposed. Some uses are individualistic, e.g. iPhone, iPod Touch, MacBook Pro, MacBook Air. The use of multi-touch technology is expected to rapidly become commonplace. Biologically inspired, often hyphenated as biologically inspired, computing, also bio-inspired computing, is a field of study that loosely knits together subfields related to the topics of connectionism, social behavior and emergence. It is often closely related to the field of artificial intelligence, as many of its pursuits can be linked to machine learning. It relies heavily on the fields of biology, computer science and mathematics. Briefly put, it is the use of computers to model nature, and simultaneously the study of nature to improve the usage of computers. Biologically inspired computing is a major subset of natural computation. Some areas of study encompassed under the canon of biologically inspired computing, and their biological counterparts, genetic algorithms, left-right arrow evolution, emergent systems, left-right arrow ants, termites, bees, wasps, artificial immune systems, left-right arrow immune system. The way in which bio-inspired computing differs from traditional artificial intelligence, AI, is in how it takes a more evolutionary approach to learning, as opposed to what could be described as creationist methods used in traditional AI. In traditional AI, intelligence is often programmed from above. The programmer is the creator and makes something and imbues it with its intelligence. Bio-inspired computing, on the other hand, takes a more bottom-up, decentralized approach. Bio-inspired techniques often involve the method of specifying a set of simple rules, a set of simple organisms which adhere to those rules, and a method of iteratively applying those rules. After several generations of rule application, it is usually the case that some forms of complex behavior arise. Complexity gets built upon complexity until the end result is something markedly complex, and quite often completely counterintuitive from what the original rules would be expected to produce. An information society is a society where the creation, distribution, use, integration and manipulation of information is a significant economic, political, and cultural activity. The aim of the information society is to gain competitive advantage internationally through using information technology in a creative and productive way. The knowledge economy is its economic counterpart, whereby wealth is created through the economic exploitation of understanding. People who have the means to partake in this form of society are sometimes called digital citizens. This is one of many dozen labels that have been identified to suggest that humans are entering a new phase of society. The markers of this rapid change may be technological, economic, occupational, spatial, cultural, or some combination of all of these. Information society is seen as the successor to industrial society. Closely related concepts are the post-industrial society, Daniel Bell, post-Fordism, postmodern society, knowledge society, telematic society, information revolution, liquid modernity, and network society, Manuel Castells. Definition: there is currently no universally accepted concept of what exactly can be termed information society and what shall rather not so be termed. Most theoreticians agree that a transformation can be seen that started somewhere between the 1970s and today and is changing the way societies work fundamentally. Information technology goes beyond the internet, and there are discussions about how big the influence of specific media or specific modes of production really is. In 2005, governments reaffirmed their dedication to the foundations of the Information Society and the Tunis Commitment and outlined the basis for implementation and follow-up in the Tunis Agenda for Information Society. In particular, the Tunis Agenda addresses the issues of financing of ICTs for development and internet governance that could not be resolved in the first phase. Some people, such as Antonio Negri, characterize the Information Society as one in which people do immaterial labor. By this they appear to refer to the production of knowledge or cultural artifacts. One problem with this model is that it ignores the material and essentially industrial basis of the society. However, it does point to a problem for workers. Namely, how many creative people does this society need to function? For example, it may be that you only need a few star performers, rather than a plethora of non-celebrities, as the work of those performers can be easily distributed, forcing all secondary players to the bottom of the market. It is now common for publishers to promote only their best-selling authors and to try to avoid the rest, even if they still sell steadily. Films are becoming more and more judged, in terms of distribution, by their first weekend's performance, in many cases cutting out opportunity for word-of-mouth development. Thank you for attention.